Mayur Mehta, the CTO, IT, OT infrastructure, architecture, and engineering, PepsiCo. Prior to joining PepsiCo, Mayur has worked with companies like Novartis, PwC, Schneider Electric, and Siemens. Mayur was a global head of OT security architecture in his previous role and was leading a large team of security architects. Mayur has held roles of security architect, security assessor, and auditor for critical infrastructure. Mayur has also performed the role of red and blue security team as penetration test lead, as well as validation lead for supporting FAT and SAT tests of operational technology systems. Mayur holds various certifications such as GICSP, Scrum Master, etc. Mayur is also program chair of Smart Manufacturing and IIoT ISA Global Section. He holds master's degree from BITS Pilani and a bachelor's degree from RGPV University, Bhopal. Now, Mayur is going to have a brief discussion on cybersecurity in operational technology. Welcome, Mayur.
Thanks everyone. Can you hear me properly?
We can.
Okay, thanks. First of all, thanks to ISA Hyderabad for hosting me here for this particular topic, which is very dear to my heart actually. And I'm associated with ISA for almost like a 6 year, I believe. And then thanks to Rajesh and many other leaders actually in this ISA District 14 who have also given me opportunity in past to lead the education chair for cybersecurity, which has actually given me immense pleasure to learn these standards which are developed by ISA and different organizations actually. Thanks for giving a short introduction of mine. I will not repeat that. But main thing is to notice that what experience count is like I have spent a lot of years in vendor side, like companies like Schneider and Siemens. That has given me one perspective of what OT security looks like. I have been in PwC as a manager doing a lot of cybersecurity assessment in Middle East and in India. That has given me different flavor, and as well as I've been in the end user side in Novartis and PepsiCo. So that actually a mix of flavor has actually always given me opportunity to enhance my scope of thinking in the OT security. I will try my best to cover what I have learned in this specific area. But of course, I will try to open and discuss a lot of questions in the end. I will try to end this in approx 40 minutes and then take questions actually in that sense. One important message I want to show here that this presentation is purely uh, on the personal capacity. It's not employer because I'm also associated with PepsiCo and CTO for ITOT part. So this is very important message I wanted to start with. Hope everybody is safe and fine in their respective places in this difficult conditions. I will be covering few topics here. Start with the definitions and then Purdue model, going over the risk at different levels of Purdue model, defense in depth approach, standards, and specifically talking about IAC 62443, which is also related to ISA standard called ISA 99. As well as I will talk about in brief about the new sections which is formed as Rajesh sir mentioned in a brief. I'll take a couple of minutes on that as well. I will stop by Purdue model after covering Purdue model and then see if there are questions and then I'll land in the last slide to take further questions in between. I would encourage if you can keep posting your questions, then I can take it in later on, right? Because one thing to notice that this is virtual. I mean, we wanted to have this session in person in May month of March, but it was not possible because of COVID and other conditions. So that will be very interactive if I have a questions and I can actually answer them, because running through the PPT will help you at certain level. But if you have some questions specifically on some areas, that will be also helpful. Another thing is I'm not covering any particular model or particular company's marketing material here. So purely this is a technical discussion. There are not even a single company's solutions being promoted here. So I do understand whenever you talk about Purdy model or different risk, you have a lot of solutions already in place. I'll give examples of some, but not name them. But of course, if you have a lot of questions regarding what to choose, what not to choose, I can cover them in the last few minutes, right? So start with the definitions. I picked this from Wiki so that it is easy for you to digest. Cyber security, or also call it computer security or information security, is purely talking about the protection of computer systems and network from theft or damage to their hardware, software, and electronics data. So this is the main area which talks about cybersecurity. And when you talk about operation technology, this is like a hardware or software dedicated to detecting or causing a changes in a physical process. So this is the major change. So you talk about security, it's wide. It can be applied to OT, IT, or any sector in the world. When it Can I request everyone to mute, please? So when it comes to OT security, OT specifically, it does a change in the physical process. So it is like in the picture you can see there is a car manufacturer who is producing automated way. Their molding, shielding, and the complete process is automated. So there is something to do with the physical process. That's where it talks about operation technology. How we use the terminology is IT for information technology. This is the same term for OT. OT comprise. I will talk about OT in bits and pieces in more slide. I mean, most of the slides are covering OT actually in detail. I will not go for cybersecurity because I have taken sessions in past, and as well as there are dedicated sessions required for cybersecurity to be covered in detail. But what is important for us to know is whenever we talk about cybersecurity, it rolls around technology, process, and people. So it might be having a technology related standards or regulations, or a software on a new innovations. It might have a process related standards and SOPs, or GOPs, which are actually used in production lines or production environments. It has a lot to do with the people, safety, people trainings, people behavior, and as well as the way they actually act or react on those industrial automation products. So this is also related to people, and that's the cybersecurity also rolls around this. And when it comes to CIA model, which is a very unique in cybersecurity, which talks about C is confidentiality, I is integrity and availability. So security in nutshell is all around these three pillars. Your products, or the main important pillar to protect in your company might be confidentiality if you are producing a lot of IPs. If you are a banking sectors, then integrity is also very important, because if in my account today is $1,000, that tomorrow it should not become zero. So there are a lot of integrity stuff, as well as when it comes to pharma, the formulas, and as well as the combinations of that is very important. So integrity becomes very important. Availability is one pillar which is very important, specifically in manufacturing sites, because if your IT website goes down for a maybe for hour, you might not be able to look at what is your balance, or you might not be able to transfer the amount, but you can do that later on. But when it comes to production, if it goes down for 1 hour, it has a long implication, cascading effect, as well as the lot of loss in terms of what you call standards or the regulations which they have to follow. So these CIA are the basic pillar in the cybersecurity. um, I mean, I will not go, as I mentioned, in cybersecurity specifically in detail, but these are the ones which are actually very critical to understand, right? When it comes to OT, it's operation technology. As I mentioned, it also refers to industrial control systems, and in ISA standard you will find this mostly referred to IACS, industrial automation and control systems. These are the interchangeable terms, but main thing is operation technology is comprises of many systems, and so-called industrial control systems. And if you can see below that, there are many types of industrial control systems: SCADA, DCS, BMS, MES, and so on. And um, the unique part of OT, it does not run on one or two specific protocol. The variety of protocols, when I say protocol, these are the communication channels, not the channels, I would say the communication protocols, which are actually required to communicate between individual assets. I will talk about Purdy model. You will understand what I mean by assets and ICS component. But these protocols, actually, if you look at, they are huge in numbers, and they have like a very unique way of communication, the way they are structured and the way they are actually built upon specifically targeting their own. So for example, Siemens has their own standards for communication, and so on other companies have. So these are the major differences from IT world actually in this specific area. And as I mentioned in the previous page, these industrial control systems terms like SCADA, DCS, PCS, and so on, they are predominantly used to supervise or control your physical process. Because if we talk initial page about the physical process, these are the ones which are actually mainly used to monitor or control. The way they are used is purely based on the geographical or the criticality of the process. This slide will be shared, so I will not encourage you to go through this now, but I think my main purpose was to build this slide was not only to give a presentation but also to share this later on, so that you can be referring this for your understanding later on, right? So this is one of the major slide, or the main slide I would say, I want to cover in this session. So when we talk about OT, operation technology, or the physical process, starts from level 3. So basically, I say 95 started talking about the Purdue model actually. And Purdue model, initially when it was developed, it was not comprising of level 3.5 or 4. I mean, many companies call it interchangeably. They call it 3.5, some company call it 4, some they just not name it. But I say 95 when the standard was developed, this particular layer, the DMZ, demilitarized zone, was not actually covered. And one of the major reason, because the security or the connectivity from IT world was not that high that time, right? So uh, starting from the level 0, you can understand these in the upper way, so that it is easy for you to remember for long term. Level 0 is the one layer which talks about your actual physical process in the plant. So you will have your robots, your motors running, your conveyor belts. Your motors are controlled by drives, and you have a lot of sensors on the field, taking care of the pressure, temperature, or the physical location of a particular material actually on the plant. And you have nowadays AGVs, that automated guided vehicles actually, which picks and places the materials automatically through IIoTs or Wi-Fi technology. So there are a lot of physical movement that happens at level 0. This is where the actual production takes place. Those productions or the physical movements are actually controlled by something called PLCs, which is level 1. And these are the areas where you will have a PLCs controlling through the program. So there are 5 different languages in which you can program the communication patterns or the input output which you want to set up. I mean, it depends totally on the what you are producing and the way you are want to commission a plant. In detail we can cover later on in one of the class, but in short, PLC is a brain which drives your automation at level 0. When you go up, these physical machines or the PLCs, RTUs might not have a small HMIs to look at what is going on, and even if it is, it will be only a single machine which you need to monitor. But when you have a large plants or a large geographical situation like a distribution centers, you need to have a central location where you can actually run and operate your productions. So that's where your level 2 comes in. You have SCADA or DCS or central HMIs machines, which are actually showing more than one PLC RTUs in that central location. And you have a lot of processes involved which you can actually visualize in larger control system rooms. Each and every sensor or actuator, actually when it communicates to PLC, it has a unique tag which is actually attached to the process. And that's where the level 3 comes in. When you have these processes run for many months, and your management want to see how you have performed, so your historian data comes into picture, wherein all these tags get recorded with the timestamp, and as well as the process values and all that. So that get captured and used later on in the production improvement areas, which can be integrated with your ERP systems and SAP systems. And as well as you have a lot of trend possibilities in your historians. You have OPC communication above, engineering stations, which are actually uh, predominantly used for programming your level 2 and level 1 systems, because as I mentioned, there are 5 languages to program a PLC. Similarly, SCADA and HMIs need to be programmed because they either run on Windows machine or native Windows machines actually, or maybe even provided OS. So they are softwares which is actually hosted, which are hosted actually in engineering stations. I will talk about 3.5 in a bit later. And then you have a level 5. I mean, as I mentioned, I say 95 was talking about level 3 and directly level 5, integration to enterprise solutions. More and more security threats, more and more connections actually has actually increased the what you call threat vectors or attack vector. These are the terminologies used in the cybersecurity term. So any connections which is a possibility for attacker to get inside your production area is attack vector for us, right? So these are the attack surface, sorry. So these are the areas specifically the DMZ covers. So you have MES, manufacturing execution systems, or historian, or any other services, for example, patch management, antivirus, or a third-party vendor connections to a plant. Mahesh, can you mute other participants, please? So this is specifically 3.5 area covers that IT OT integration, and that becomes very critical when we are actually architecting or designing a plant. When it comes to designing a plant in a greenfield, that is not a challenge, and that becomes a easy cake because we know what to do. But when it is a brownfield, what is mean by brownfield is the plant which is running for many years, and you want to do enhancement in those plants. So that becomes a challenge because these connections which you see very nicely in picture level 3 2 and 1, even in the level 0, they are very complex the way they are actually configured. They are not same as IT server room, right? IT server room has a lot of wiring with the tag. You have a server cooling area, and then you have everything in that room. Production area is mix of lot of physical cables. Your as I mentioned, the different protocols comes in different types of cables, different types of connectors and converters. All that put together is forming your level 3 to level 0 actually. So putting a DMZ which can actually segment these communication in a secure way, it becomes a difficult what you call altogether different channel. So that's where I wanted to put a pause. Maybe if there are questions I can take, and then I can drive towards the security as well? What are the challenges and the security areas? Okay, so if there are no questions at this moment, I would I actually again pose as I mentioned in the last slide to take all the questions. Uh,
Mayur, there
Typically,
is a question where it says there are
mhm,
discussions going on Purdue model that it
yeah,
might fade away in the coming years because of
mhm.
smart devices where it directly talk to the cloud. Any thoughts on this? That's what Sahan wants to check with you.
Yeah, sure. That's a very good question. And when I will go to the last slide, which is talking about smart manufacturing or IIoT, that's where these enhancement are required. But definitely, Purdue model will not fade away. Just let me ensure that Purdue model has not come just a year or 2 years of research. It has come after many years of discussions and models. These IIoT devices are popping up in last couple of years. Of course, they might talk to the cloud, but when it comes to giving I mean basically these IIoT or IoT sensors or devices are actually giving back the communication at this moment by sensing already. I mean, this is not that it will fade away later on. It's already a lot of connections between level 0 and level 5 is already taking place actually. But major thing to understand, when you want to run a production, you still need to have a PLC. I mean, your sensors will provide you that feed directly to the top management, and there might be a lot of already customized look and feel already set up in cloud or maybe in house to see what exactly in running in a level 0. But when you want to run a production, you still need to have your PLCs controlling those processes, your SCADA and your operators looking at those. You might see a number of people reduced in level 2, because at this moment, if you go to any generation unit, you will see a big controls what do you call area where you have like a 10 20 people sitting and just continuously watching the process of the fluctuations and all that, right? But when it comes to later on machine learning or new technologies, these specific level 2 level 3 will see a lot of indulgence or maybe connections to the level 5. So complete Purdue model fading away is definitely not going to happen so soon, but you will see a lot of zones and conduits actually mixing up and feeding the data up to the cloud, right? And that's where the security becomes more challenging, because when you have something in your hand to control, you can actually still plan, but more and more you start connecting without properly. I mean, everything need to be architected and designed, but the security is one of the major pillar which will also drive these connections actually. And just to note that IC 62443 or ISA 99 is the major standard which has taken many years to come to this stage. I have one slide to cover a high level of that. That still talks very clearly about systems and zones and conduits. And the recent updates are also talking about that. I mean, that's when I'm saying recent, not it published. I have reviewed that recently. They're still talking about those zones and conduits. Yeah. Any other
Okay.
questions
Thank,
before I move on?
yeah, thanks, Mr. Mayur. Just another clarification.
Mm-hmm.
Am I audible? Am I audible?
Yes. Yes.
Okay. So a good question posted by a colleague here about the IoT devices which are on field sending data directly to the cloud, right? Analytics purpose. So they
Mm-hmm.
mostly are IoT-based monitoring solutions, right? Which augment, predictive analytics and so on and so forth. Have a question. Sometimes these IoT gateways, which are directly, kind of, are plugged into the PLC and the layer two components, they may go into a phase where they start actuating and passing commands to the control processes as well. So if that happens, the IoT solution is not going to be just exclusive for monitoring purpose, but it may
Mm-hmm.
also play a role in control processes. So if that happens, the ambiguity that I have is, how is it going to be, kind of overall orchestrated? Because there are some supervisory and control systems which are in the present model as you say, and there is also a track that is leading to cloud-based, IoT solutions, which are also passing on controls. So how would that, how would that conflict ever get?
So, I mean, in between there is a disturbance, but what I can hear from your question is presently, mostly they are actually monitoring mode, but they will also in control mode, and how that will be in still in control of the right production. That's what is your question?
Correct, correct. Because we may end up seeing two commands,
Mm.
right?
Yes. Yeah.
One is organically from our, SCADA and control systems.
Hmm.
Another one is
Hmm.
also, with the IoT empowerment and all. So they may, if they have a direct, placement in the IoT components directly placed into the PLCs and others. So if they also pass on some commands, so then
Mm.
how is this operation going to look like in the future? Just a ambiguity that I have. So.
No, that's a very good question, and that's where these the discussions or the sections are actually driving through. I will cover about that in the last slide, but majorly whenever you have a PLC taking a control, I mean, when even the level two, which is supervisory control, it generally don't give all the time commands. It is purely to monitor if there are any changes in the set points actually. So I mean, your PLCs are well equipped to take care of the control, because it has a input which it is coming from sensors, and it has a program in the output sections, right? And these inputs are majorly deployed the sensors itself. Now when it comes to IoTs, I mean, IoTs again, when I am showing in the figure the drives which is there already, drives became IoT long time ago. Actually, I myself have tested those devices being an IoT device itself. So the what do you call input to the PLCs might change from the different inputs which are already. I mean, you might have a sensors which are industry-based sensors. Now it might go to the different types of sensor or IoT sensors actually. But again, more or less, when you are designing or setting up your plant, you will need to consider what exactly is the main reason behind your setting up a plant, right? If you are a pharma or a for example automotive company, you will have a defined process, and that has actually itself a process, that's called commissioning, and that goes through a long process of understanding what exactly you're picking and placing, and then different processes and all that, that put together forms in programs. Actually, it might be already written libraries, or it might be a uniquely written program. These programs need to be also uh, agile actually to take these IoT inputs later on. But of course, these will also feed it to the SCADA supervisory to take further more decisions. But as I mentioned, more or less, level one has to be more intelligent to able to get these direct feeds. Just to give you example, there are I will not name the companies, but I have done the assessments on those companies. They are already taking the orders from the customers directly and shipping the right color or right color of car with the right uh, softness of their seats and everything. There are companies who are shipping their medicines very unique for individual customers, and that has already reached level one. So it's not just level five commanding production what to produce. There are already internet or cloud are already reaching to the level one. But again, it totally goes back to what is your security appetite, and as I'll talk about, security is a risk management process. It's purely what you want to control and what you want to manage in your entire process. There are a lot of benefits of having these what do you call unseen issues, which are actually were triggered or consumed at level 0 and 1 itself, and that can has long term effect, or maybe I would say organically they will actually give a lot of benefits to the companies when they can see large or the big data inputs of those sensors and all. But at this moment, what is produced in the companies, they are actually not even, companies are not even ready to change their old XP or Windows NT machines actually. So if they are not able to upgrade their systems, then digesting what you call heavy food with a low liver capacity, I think that will be a very big disastrous situation. So it has to be combination of how to increase your security posture as well as your capacity of enhancing the production.
Sure, thanks. Thank you.
Yeah. And this is where, I mean, in this slide actually I was trying to cover that as well. So in typically if that covers, I will continue, right?
Yes, please. Yes, please.
Yeah.
Thank you.
So in this slide, actually, I mean, this is typical. I mean, this you cannot go to individual companies, but typically your CIO organization, which is the information organization, and the plant organization, which takes care of your productions, are actually generally different. And that's where it arises that you can see that industry estimate that 70% of the organization do not have a visibility what's going on in ICS OT. And that's where these IoT sensors or the sensors sending the data directly to the cloud or giving a lot of predictive maintenance features are actually evolving, because that's where the difference comes. Because when it comes to organizations actually who has already faced breaches, they are very clear about what they have to enhance. But there are companies, and it is very clear that every day the production don't run as it is planned a day before. So there are bits and pieces of the problems, hundreds of problem, and one of them is a security problem. But when it comes to security problem, then it all goes down to what you want to improve actually. And as the suggestions or the graphs mentioned, that 79 or 80% of the organization already have seen small or bigger kind of a security breach in their industries. And as you rightly mentioned, there are many benefits of driving these um, connections from level 0 and 1 to the top, but there are a lot of what you call connection issues now all put together. Who owns the security of a manufacturing, right? Because CIO has the CISO organization, which is taking care of a in generally in organization has a CISO, which is a chief information security officer, falls under CIO organization, which is a chief information officer, has its own challenges in running a plant, running a company, or corporate offices or offices. But when it comes to the plant manager, he has a different kind of challenges running a plant, right? He has his production needs, its warehouse, its supply chain challenges, his production day-to-day challenges, as well as a lot of problems in terms of managing a big staff who is actually on the shop floor. And when it is one plant, it is fine. When you have 100 or 300, 500 plants, the challenge goes up. But again, when you start mixing up sites with IT and OT, the challenges are not going to decrease. And that's where you need to start understanding what are the things which are upcoming. So as I mentioned, ICS and both the side, IT and OT side, both the side are actually clear that you need to have more connections. Currently, there is one path, which is again a very many companies are running that flat. So you have level 3 talking to level 5 in the flat network. I mean, when I say flat, there are no barriers. So you can actually ping a PLC. You can control the PLC from office layers. There are many different problems actually already available, even though they started connecting. But that's not the end. That was the start actually, because IT/OT has started connecting because of ERP connections, because of vendors connection, because of warehouse connections, and because of many audits done. Because many companies, and I would say, because I've been in one of the that role actually, many companies, when they do the cyber security assessment of a plant, they start sending reports to the higher management saying that the products are vulnerable, the systems are not patched, the systems are not having antivirus, and so on and so on so forth. The company start building up that kind of infrastructure, and they start adding more and more connections to IT world. Now again, that IT OT connections are actually increasing because of all that enhancement which was required, which was not required earlier. And then you have number of diverse people. The IT people don't understand what is production guys don't understand even a port. When you say port, they generally think of a physical port and a switch. And I'm telling this with with the experience, because when we talk to them, they have very clear definition of what they have to run in a whole day. So when you talk about ports, which are the services which any computer required to operate in particular environment, they don't even understand that. So there is a huge mix of people or diverse people. I would say they are expert in their own fields, are running entire business, and that has more and more challenges. Situations like COVID-19. I mean, you might have known like half of the industries have had to shut down their productions because they were not able to send the people to the plant. They were not able to commission their half commission plant. They were not able to even produce the 100% capacity, even though there are industries like food, there are industries like critical industries which are actually exempted from governments or countries. Actually they are able to run, but again they have a lot of challenge. So that will bring more and more connection or remote monitoring, commissioning, or running a plant, unmanned plant. We used to laugh actually a few years ago that the plant, and that's the true. You will see that in many years that the plant will have only two people sitting down to run a production. One will be a person, and one will be dog. So person will be taking care of a dog, food and everything, and dog will make sure this person doesn't touches anything on the production. So that's where your automation is going to. And that is not something will happen in a year or something, but that is an environment you will see in many more years to come, and your connections will be more intensive, and that will drive to these IT/OT convergence very heavily. OT security issues, or I would say the major attacks, has a long history. But when you talk about ICS security, you can never leave a Stuxnet, because that is where, I mean, that is not the only 2010 which is the first OT security attack happened. But good thing to remember that this is the attack which has actually opened eyes of all the vendors, end users, system integrators, and so on, to actually look at security very seriously. Before that as well, there were attacks. I have a lot of long list of attacks in before 2010, but they were not actually making that news and impact. But the list has ever increased from that time, and then it is continued to increase every year. You have a lot of sophistication in the type of attack. For example, Stuxnet 2010, though it was 2010 when um, uh, what do you call, uh, there are reports actually which talks about the binaries which were built to do this attack were almost 5 to 10 years ago were started building up. 2007 is the one they started testing it, and as well as Stuxnet, I will talk about that in one of the slide. And as well as the recent attacks like WannaCry, NotPetya, they have actually stopped the production of entire company. They're not only talking about one or two plant, but they can swipe off your entire domain controllers and so on. Havex talks about how a vendor sites can be also utilized for shipping the wrong or what you call vulnerable firmware or the softwares to companies who believe their vendors blindly. Me being in a vendor side, I was never aware that uh, the end users believe vendors so blindly. But I have been in consulting as well as in the end user side. Let me tell you that, and we believe that whatever the software or the hard applications are built by vendors, that is how it works, and that is the best way to work. But that's not right. I mean, there are many problems in the both the side of the game actually. So these are the few examples, and these are very well-known attacks. And 2019 has seen unprecedented increase as well. A few of them I have covered here. Started in March. Again, don't go blindly that only Iranian or Chinese have the attack, because this slide has more of that covered. But just this was just to give you a glimpse of these attacks are happening every month, and these attacks might have a small or medium impact at this moment. But just to understand, when let me go back here, the Ukrainian attack, which is a very well-known black energy attack, wherein 200k people were actually powerless for a few hours actually. And 2015, this has actually driven, but 2014 December itself, they were actually sorry, 2015 December they had this issue, but 6 months before itself, the attackers were in their network. So they might have already seen small or bigger impacts initially itself, but uh, just you need to consider the kill chain process, which is ICS kill chain process has a ICS kill chain process has a two major step. One is your setting up your foot into the manufacturing sites or the environment which you want to attack, and second one is the actual execution of those attacks. So these two are very there are many steps in that, but these are the major two steps, and most of these attacks which were seen last year are actually falls under the first step actually. uh,
Mahesh, Mayur, so sorry to interrupt you, Mayur. We've got another
mhm,
10 minutes to, complete the first event.
mhm,
So
sure.
if you can complete that in 10 minutes, then you said you will also take some questions. So if you can just speed up a bit, if you don't mind.
As we took like a ISA introduction session for almost 5-10 minutes, can I take another 5 minutes because I have few things
Yeah,
to
yeah, you
cover?
have you have 10 minutes, Mayur. That's what I was trying to say.
No, okay. I mean, I will try my best to cover.
Thank you.
I mean, I might extend maybe few minutes. Okay.
Yeah, sure. Shouldn't be a problem.
Okay. um, then I need to maybe wrap up. I was thinking I'll run this video, but majorly, as we talked about Stuxnet, it is, I mean, one of the sophisticated attack, and most of the ICS expert knows the sophistication it has involved. So it has borrowed the certificates so that even if it is inserted through USB in the environment, it was seen legitimate. The search of that attack was actually within the network to see if Siemens system it can find, and then followed by it used to also see if there are any updates on the internet so that it can keep updating its own version of a malware. And then it step 4, it has compromised. It has said that it has almost 10 0 days vulnerabilities it has exploited, and 0 days are nothing but the ones which are not known in public or not having any solution already in place for the vulnerabilities which it has exploited. It has also changed the set points which actually were actually controlling the speed of centrifugages. And then it has also blinded operator not to see what is going on the level 0. So it has done all possible from level 5 to level 0 to make sure it has a full set of issues at all level. And this was one of the major issues which has opened up the eye, as I mentioned earlier. We talked about ICS Purdy model. Let's look at high level risk at each level. Insecure connections to the internet. Again, when it comes to connections made with the vendor, with internet or a cloud, this is one of the major weakness, which is a major concern area. The unsecure internet access from level 5, unsecure email connections to the servers, and down at the level 3, because there are many phishing attacks which comes with attachment to open or close the valve actually, because these attachments will look like legitimate communication from management, but when you open internally, they are running a command to operate in level 1 or level 2 systems, and that can drive a lot of destruction in the production actually area. And when it comes to level which is actually part of IT OT integration, has a lot of issues with communication that is called zones and conduit. So you have a conduit uh, which is a communication channel between levels. If you do not configure or do not plan proper segmentation, you will have a lot of misconfigurations and firewall, because day-to-day operations guys will have access to sometime firewall, sometimes central team will have a firewall access. And when you do not have a proper management of these firewall change management, it leads to a lot of misconfiguration, insecure remote access. Many of the companies setting up their own access points and providing the solutions. There are ways to increase the security, but these are the major challenges which these connections face. There are systems which are required to run many services, patch management, antivirus, and so on. They're also placed in this specific area. They need to have a connection, because if you want to run an updated antivirus, you need to have an updated signature of that, and that leads to a connection to internet or maybe your global data center that resides here. So that is also one of the target point if you do not do the proper segmentation of your zones. In level 3 and below, because these are old and weak systems, any attack vector can actually drive these to the issues. That's where these becomes a very vulnerable levels. Infected USBs, for example, Stuxnet has actually shown, even if you have an air gapped system, which means you do not have any connections to internet or IT, still you can actually impact. So infected USBs, in unshared file transfer, vulnerable software, unpatched systems, and so on. This list goes on actually, because this is major area where your production runs. So you need to also look at how to individually categorize these risks, because individual servers or business systems or machines will have their own risk and what you call vulnerabilities, which need to be segmented. More or less your weak PLCs, password, and vulnerable HMIs, hard-coded password. These are the issues which residing from many years to come, and they will still reside. Recent attacks like Triton has seen like safety PLCs attack. There are PLC were attacked for many years actually. I mean, you can find in Showdown, which is a search engine to see what PLCs are already sitting on your production, but are also facing internet access. So there are many issues which are already residing at this level, and then you have a level 0, which is bringing more issues. Of course, the firmware attacks and all very sophisticated, but when it comes to IoT or systems which are connected to their WAN systems, unsecure WAN systems, that brings a lot of different kind of challenges. Again, when it comes to um, uh, defense in depth approach, there is no silver bullet for any company or any organization to solve these issues, but there are approaches which I brought here. Of course, there are many enhancement done in recent past, wherein specifically the segmentation becomes the first and most priority for any organization to make sure their right component sits in the right layer. Their DMZ zone becomes very critical, and that is properly managed. You have proper patching and secure file transfer mechanism, backup mechanism, and so on. And one of the most important or most rising thing, which is in level 1 and level 2, 3, is deep packet inspection of or anomaly detection. This is driving a lot of attention, and all the solutions now, if you search in on the Google OT security solutions, you will see they are falling under this bucket. And that has a major intent to do passive vulnerability management, which is not harming any production area, but sensing what's going on, and in backend reverse engineering of that particular communication on that particular channels, and see what kind of vulnerabilities are actually flowing in that network. So that is driving a lot of attention of all the companies in small or medium what you call speed. But again, this is one of the major area which is seeing. And as I mentioned, this is something totally depend on the risk maturity of a company, and it's a risk management what you call process. You will have a lot of connections made in a secure way in level 4. There are many companies who are going to data diode and one-way communication process. So that is in short I could cover. There are various standards which actually talks about ICS security. 62443 is one of them. NIST 882 is one. NERC and so on. These are the standards which has come for many from many years with a lot of security experts and as well as the industry experts involvement. And one of them majorly is 62443. 62443 is not just a one standard. It's a library of a standard, I should say. So it is majorly covered in four pillars. General is like for general terminologies understanding. Policies, procedures. This is purely for end users as well as system integrators to make sure they run program their production in a right way. Level 3 is again majorly for system integrator as well as vendors who provide the systems as a whole solutions. And the last one is the component, which is purely for the vendor who produces these industrial automation products like PLCs, drives, HMIs, and so on. And these standards, some of them are in a release stage, some of them are in draft stage, but it is one of the best standards in ICS field, which is evolving. And same in line with that, actually, smart manufacturing and IoT division has been formed, and this division is purely focusing on all the challenges which are actually rising because of these industry 4.0. And if I can show quickly, I'm not sure if this opens here. So this is a section, I would say, when I have been like appointed as a program chair, but there are many small divisions, not division, I would say the technical committee is being formed, uh, whether it is cloud or cybersecurity or AI and so on. These are the major top-down approach which we are looking at. How do we take these different challenges in smart manufacturing will be solved through ISA. And this is one of the recent section which Rajesh has talked about. And this is one of the what do you call good to connect section. I mean, even if you're part of one or two sections, you can still be enrolled to that, and you can take involvement in initial phases itself of driving a industrial automation standard for smart manufacturing and IoT division part. uh, I will end here. I will take maybe one or two questions before um, Mahesh take over the session.
Hello, Mr. Mayur. This is Nishant, and
Hi.
thank you for the presentation. I had just one question.
Mhm.
With the advent of industrial IoT, we have seen increased connectivity of sensors at basically the level 0 of the Purdue model,
Mhm.
connecting to say MEA systems or larger systems across the internet.
Right.
So, given this context, we have seen cybersecurity measures and cybersecurity attacks primarily being targeted at the level 4 or level 5 currently. So, because
Mhm.
they predominantly connected to the internet from a historical perspective.
Mhm. Right.
But things are changing now because the sensors themselves are distributed in a very large geographical area, and then they use other protocols to communicate directly, bypassing level 2, 3, and 4, and could probably go to level
0.
5 directly. So, given
Mhm.
this, how is other standard organization looking at cybersecurity at level 0 itself? Because that is a vulnerability that could be exploited at any point of
Mhm.
time.
Yeah.
Uh,
So
so that is what I wanted to understand.
that's a pretty good question. And let me tell you, uh, the standard which I talked about just now, the 62443, the component product part, the 4.1 and 4.2 part specifically talks about the security in those components. So either you deploy the existing industrial control systems or the newly developed IoT or IoT component. There
Mhm.
are very detailed security requirements which is covered under 4.2, that's called CRA, SRA, and so on. They call it. They are also divided into the security levels: security level 1, 2, 3, 4, and they
Okay.
actually they go in detail about if you are using a particular protocol and what kind of a standard security you need to be already in place if you are connecting that to the level 1 or level 5, right? Because more and more these components were actually connected. The existing industrial automation products were connected to level 1, hardly to the level 2, because sometimes MES has the connection, but they were hardly
Right.
connected to the internet part. But now these standards, ISA 99 is actually enhancing their standard as well as there
Correct.
are 95 is also going through a review and an upgrade, because per D model comes from there. But already the existing sensors which
Hmm.
need to have a security, I think that is a big input if these standards can be followed. um, I'm not looking for any certification again. Don't confuse, because ISA Secure is one of the body of ISA which also drives certification of product, but certification talks about communication robustness of a particular device, but security
Hmm.
is more than a availability issue, right? So there are a lot of requirements which are actually falling under 4.2, which actually covers a lot of security vulnerabilities which can be solve if the product is developed in a right way with the right security requirements.
Okay. So from what you had explained, I understand that the standards are already looking at that as an active area of research and development, and products are
Exactly.
expected to be more secure as its footprint expands.
Exactly. And let me tell
Okay.
you, one of the
Thank you.
product I myself have worked in past, which was called Secure PLC. Of course, it is not the 100% foolproof security, but it brings in a lot of features of disabling unused port, providing IPsec tunnel, and so on. And it has SIM integration as well, so you can integrate your security operations center directly to the PLC level. So that kind of features are
Okay.
already coming in these devices.
Okay. Okay. I understand.
Okay.
Thank you, Mr. Mayur.
Mayur, Mayur,
Mm-hmm.
this is
Hello.
Sachin Dahake from Technimon.
Mm-hmm.
I just wanted to know specifically for level 0 and level 1, there are wireless devices connected to wireless controllers. So there are chances that they may also come under attack. So whether do we have any standard which defines any guidelines for to avoid these attacks?
So specifically, I mean, of course, you have some part in that covered in ISA 62443, but specifically ISA 100, if I'm not wrong, covers about the wireless usage in the production area. And I mean, of course, you will see the general guidelines from using advanced mechanism to do the what you call your SSID segmentation from IT world and so on. But specifically talking about standard, yes, ISA 100 covers that, and 62443 also talks about that in level. As I mentioned, levels are nothing but SLs, security levels, SL1, 2, 3, 4. There are 4 levels, and one of them levels talks about wireless security as well. That's precisely in 3.3 section, and as well as in 4.2. So these two are covering that part.
Okay, thank you very much.